Hi, and welcome to this section of the Basic Math Word Problem Tutor, where we're going to tackle problems that involve subtraction of fractions. So in the last section we did problems that dealt with adding fractions together, and the big trick there was just to make sure that your denominator, your bottom number in the fraction, has to be the same in order to add fractions together. And if they're not the same, then you as a student get to use all the tricks that you have with math to actually make them the same number in the bottom, and then you can add your fractions together and then you simplify them at the end. And we're getting practice with that in that section. Now, subtraction of fractions is very, very similar, and that's the good news. So it's not like you have to learn really a totally new skill. It's really the same thing that we've been doing before with adding fractions, except now we're going to actually subtract them, and the same kind of rule applies. The denominator, which is the bottom number in the fraction, okay, has to be the same between the two fractions in order to subtract them. And if it's not the same, then you get to use your tricks, your math tricks, to make them the same. And we're going to do that a lot in this class here, okay, in this course here, in this section. So it's really nothing different. The bottom numbers have to be the same, and once they are the same, the bottom number, the denominator, goes along for the ride just like it did in the last section. And the top numbers, instead of adding them together like we did, now we will subtract them. So it's really very similar. Once you know how to add fractions, subtracting fractions really is not that hard, okay? So let's jump into the first problem and get some practice with it right now. The first problem says you have 3/4 of a cup of water and you pour out 1/4 cup onto the ground. How much water do you have left in the cup? Okay. So the first thing you need to ask yourself, since this is a word problem, is well, what do you have to do here? Am I supposed to add these numbers together or subtract them, or multiply them or divide them? And so in order to do that, you must understand what the problem's asking you. So it says you have 3/4 of a cup of water. So I have a cup of water here. I've got 3/4 of a cup, and I pour some out, okay, onto the ground. How much do I have left? So you see, because I have the 3/4 cup, and because I'm pouring some out, that means you're going to need to subtract these two numbers. Because I have some water, I'm subtracting it by pouring it out. I'm getting rid of it. I'm dumping it onto the ground. And so the water is going down on the glass, inside the glass, so I'm subtracting that water that goes into the ground. So that's how you know that you need to do a subtraction here, okay? And so what you'll have to do is, you start out with 3/4 of a cup of water. Okay, this is how much water I have to begin with, and I'm subtracting out 1/4 of a cup of water. So in pictures, if this is your cup of water, and this line right here is 1 cup, okay, then 3/4 of a cup is going to be right here, roughly, okay, because, here's going to be 1/4 of the cup, and then here will be 2/4 of a cup, 3/4 of a cup, and then 4/4 is 1 whole cup, so that's 1 cup right here of water. So 3/4 of a cup will be here, and then when you pour out some water, like we said here, this is about 1/4 of a cup, 1/4 of a cup. So we're going to be getting rid of about this much water onto the ground. So the water level is going to come down by this much, and the question is how much is left in the cup when we do it, when we actually pour it out. So in order to find the answer, you have to do your math here. So just like when we were adding fractions, you look at your denominator, your bottom number here, and they must be the same. In order to add fractions, in order to subtract them, the denominators must be the same. And here they actually are already the same, because this problem is that way. So it comes along for the ride. You don't subtract these, you don't add them, you don't do anything. You just carry it along for the ride, because this is a subtraction of fractions, and the denominator just comes along for the ride. Okay? So it's easy. It's really easy. Now, the top numbers, we just simply subtract them because we're doing a subtraction. So 3 minus 1 will give you 2. Okay? So you see, subtracting fractions really isn't very hard. The bottom number has to be the same, and if it is, you keep it along for the ride, and you just subtract the top two numbers. So congratulations, you've subtracted your first pair of fractions here. Now, you should always look at your fractions once you write them down to ask yourself if they're in the simplest form. Okay? Because remember, there are many different ways to write fractions. We looked at that in the last section. You can have, lots of different looking fractions on the top and bottom that actually are the same thing in the end, okay? So what you need to do is you need to look at this and you need to say to yourself, is there a number that I can divide into the top and into the bottom, the same number, that will make this thing simpler, that will divide an even number of times into the top and to the bottom. So is there a number that will divide into 2? And the answer is yes, of course there is. 2 will go into 2. How many times does 2 divide into 2? 2 divided by 2 is 1 time, so I put a 1 there. And then I do the same exact thing to the bottom. 4 divided by 2 is 2, so I put 2 there. Okay? So I've simplified this fraction from 2/4 to 1/2. So what I did is I picked a number, in this case 2, and I have to divide the top and the bottom by the same number. Because I'm doing it to the top and to the bottom, then it's legal, and it's just like a seesaw, you know, at the playground. You can, if you're balanced here with 2 people on each of the seesaw, I can give him an extra pound of books, and I can give him an extra pound of books, and the seesaw will stay balanced. I can give him an extra, truckload of something else, and I can give him some more stuff. As long as I give the same amount to both sides, it's balanced. So what you're doing here is you're doing the same thing to the top and the bottom by dividing by 2. So I'm dividing 2 by 2 gives me 1, and dividing 4 divided by 2 gives me 2. That is legal, and that is why these 2 fractions are the same thing. They're exactly equal to one another, even though they look different. Okay? So just to beat it to death, if you were trying to draw this, 2/4, you divide a pie into 4 pieces, and here's 2 pieces of it. 2/4 of this pie. And if I were to look at this one, here's a pie, and I divide it into 2 pieces because the denominator tells you how many pieces you divide the pie, but I only have 1 piece, okay? I have this piece here. So you see, in both cases, this is half of a pie and this is half of a pie, and so the fractions look different when you write them down, but they're showing you the same thing. It's this much pie. It's this much pie. They look different, but they're telling you exactly the same thing. And that's why you try to simplify them into the simplest terms, okay? So the answer to the question that you would write on your test is, if you have 3/4 of a cup of water and you pour 1/4 out on the ground, you'll be left with 1/2 of a cup of water, okay? So that was a pretty easy problem from the point of view of the denominator was the same in both fractions. So I was able just to do a quick subtraction and do it. And as we go on and do more and more complicated problems, we will have to sometimes make the bottom numbers the same on our own, because maybe they're not always the same to begin with in the problem. Okay? But that's just an extra step. We'll tackle it. It'll be easy. Okay? So the next question says, a tree is 7 7/8 feet tall, and you cut off 2 3/8 feet from the top of the tree. How tall is the tree now? Okay? So you need to think about this. Am I going to be adding or subtracting? Well, you know a tree is 7 7/8 feet tall. Let's just say it's this tall. Okay? And I cut off 2 3/8 from the top. And the question is, how much tree, or how tall is the tree now? In other words, how much is left over? Okay? Because you're cutting the tree and essentially throwing it away, you're basically subtracting the height of the tree. Okay? Because if you have a tree that is this tall, 7 7/8, let's say, and I cut off this much from the top, in this case I'm cutting off 2 3/8, and I'm asking myself, how tall is it now? I'm doing a subtraction. I'm saying, how much did I start with? How much did I chop off from the top? And I'm subtracting those two, and that's going to tell me how tall it's going to be in the end. So that's why you know you need to do a subtraction here and not some kind of addition or multiplication or anything. You have to understand what the problem's asking you, okay? You're not going to add these numbers together because that would be making the tree taller. If you add them together, you must subtract them because you know you're chopping the tree down, okay? So, how do we do this? The tree was 7 7/8 feet tall, and we're cutting off 2 3/8 of the tree. So we're subtracting, this is the total height of the tree, and we're subtracting off what we cut, which is 2 3/8 feet, and now we want to see what that equals, okay? Now, remember back when we added our fractions, this is just a mixed fraction. There's nothing huge about this. This just means, for instance, if this is 7 7/8 feet, this means that if you get your tape measure out, it's 7 feet, okay, and then 7/8 of a foot. So it's telling you it's 7 feet, it's almost 8 feet, because this is 7/8 of a foot, which is almost a whole foot. So it's over 7 feet, it's less than 8 feet, And that's what this is telling you here. Now remember back when we did our addition of mixed numbers like this, we just added these two numbers out front because these guys are along for the ride. We know it's at least 7 feet plus 2 feet. So we would just add these two numbers together if this were an addition problem, and then we would add these fractions together, and that would be our answer. But this is not addition, this is subtraction. Okay? So the first thing I'm going to do is I'm going to subtract 7 minus 2, which is going to give me 5. Okay, 7 minus 2 is 5. Okay? Because if I have a tree that's 7 and 7/8 and I chop off 2 and 3/8 feet, I'm at least chopping off 2 feet. I'm actually chopping more off than that. So I'm at least going to have 5, and I'm going to have some fraction left over because I still have to deal with these fractions, but the whole numbers here can be subtracted because they're whole numbers. Okay? So what I'm going to have here is I subtract 7 minus 2 to give me 5, okay? And then to deal with the fractions, I subtract them, okay? So I have 7/8 minus 3/8. So you see, all I'm doing is subtracting. I take 7 minus 2, and that gives me my 5. I take 7/8 minus 3/8, and that's what I'm going to work on next, okay? And the reason that I have a plus sign here is because this is a mixed fraction. So just like 7 and 7/8 really means 7 plus 7/8 of a foot. That's what this means here. When I do the subtraction, I'm just saying I got 5 feet left over plus some little fraction that I'm going to find out because I'm going to subtract these fractions here, and that's going to be my total fraction. Okay? So what you're doing here is a subtraction. You're subtracting the whole numbers, you're subtracting the fractions, and I'm doing that, and then the result is just going to be stuck together as a mixed fraction. Okay? So let's work on doing that. 5, okay, plus, and then in parentheses here, notice that these denominators are both 8. That means they're both the same. So 8 goes along for the ride. I don't add him, I don't subtract him, I just keep him because he's the same. And then I just subtract the top numbers, the numerator. 7 minus 3 gives me 4. 7 minus 3 gives me 4. So what I have here is essentially 5 and 4/8. Okay, that's what I have here. 5 and 4/8. Okay? And don't get scared off by these parentheses. Okay? Don't get scared off by this stuff. This is just me grouping things together. Okay? It doesn't really mean anything other than that. I've got my 7 minus 2 giving me my 5. I want to remind myself that I'm subtracting these fractions totally separate from everything else, so I just kind of put them in parentheses here. Okay? And I do this subtraction, and then at the end I just kind of drop it because it's just kind of a note to myself what I was doing. You can drop these parentheses totally out of the problem and it won't affect anything, okay? So I have 5 and 4/8, and you always must ask yourself, is this fraction fully simplified? Can I divide the top number and the bottom number by the same number and make this thing simpler? And the answer is yes, you can do that because, think about it, if I divide the top by 4 and the bottom by 4, it's going to make this simpler. 4 divided by 4 is 1, and 8 divided by 4 is 2. So the answer is 5.5. And 5.5 what? It's 5.5 feet tall. So if I start with a Christmas tree that's 7 and 7/8, and I subtract 2 and 3/8, okay, I'm going to be left with a tree that's 5.5 feet tall. And you can see that you could never predict this just by looking at these numbers that it would be 5.5 feet. You have to work through the math. So again, when you have these mixed numbers, go ahead and subtract them, okay, and hang on to that, and then subtract your fractions separately, and then at the end you're just sticking it together as a mixed fraction, okay, and then you simplify your fraction, and that's going to be your answer. Okay, the next problem says if the temperature is 75 3/10 degrees outside, and the temperature drops by 15 1/10 of a degree, what is the temperature? Okay, so this is something we have a lot of experience with. It's the weather. You wake up, at some point during the day, the temperature is 75 3/10. That just means it's 75 plus a little bit more, 3/10 of a degree, 75 3/10 of a degree. That's the temperature. And during the course of the day, a cold front comes through, makes it nice and cold, and the temperature drops by a little bit more than 15 degrees. Temperature drops by 15 1/10 of a degree, okay? And the question is, what is the final temperature after the temperature has dropped? So, because we know the temperature is dropping, that it's going away, it's dropping, we know we must subtract these numbers. You're not going to add them, because that would make the temperature greater. You're not going to multiply them. You're not going to divide them. Those just don't make any sense. You need to understand the problem. We're starting with 75 and 3/10 of a degree, and the temperature is dropping. So we must subtract that number to find out what temperature it is after it got cooler. So we start off with 75 and 3/10 of a degree. Okay, that's how we write that. It's a mixed fraction. 75 plus a little bit more, 3/10 of a degree. That's the temperature we start with. And we're subtracting off however much the temperature fell, which is 15 and 1/10 of a degree. So we're subtracting off a little bit more than 15 degrees. It's 15 and 1/10. Okay? So what do we do next? We know we're subtracting these things. This is 75 degrees plus a little bit more. This is 15 degrees plus a little bit more. So we know we can subtract our whole numbers. We can always do that. So what we will do is we'll say, what is 75 minus 15? And if you don't know what that is, let's do it right here. 75 minus 15. Okay? Let's go ahead and subtract that. 5 minus 5 gives me 0 in this column. And we're done with that column. Now 7 minus 1 will give us 6. So 75 minus 15 is 60. So I'm going to write that down right there. I don't need this anymore, so I'm going to get rid of it. Okay? So all we did, we haven't even looked at the fractions. We're just subtracting the whole numbers here. Okay? So 75 minus 15 gives us 60. Now we have to deal with our fractions. All right, so let's subtract our fractions. So what we're going to have is, I'm just going to write it over again to make it clear. 3/10 minus 1/10. Okay? All I'm doing is I'm subtracting them separately, and at the end I'm going to stick them together as a mixed fraction. Okay? Because no matter if these fractions are here or not, I can always subtract my whole numbers, and I can subtract my fractions separately. Okay? So what I'm going to have is 60, and on the inside, notice I've got 10 in the denominator for both of these, so it just comes along for the ride. You don't add it, you don't subtract it, you don't do anything to it, you just carry it on. And I just simply subtract the two numbers in the top. 3 minus 1 gives us 2. Okay? So I'm just going to stick my fraction back together again, my mixed fraction, 60 and 2/10. Okay? 60 and 2/10. And that is really the answer, but you should always ask yourself, can I simplify this fraction? Can I make it simpler? Can I divide the top number and the bottom number by something that will make this thing simpler? And I think the answer is yes, you can do that. If I divide the top by 2 and the bottom by 2, it will make it simpler. So let's try it. 2 divided by 2 is 1, and 10 divided by 2 is 5, because 5 times 2 is 10. Okay, so you see I've changed it. So this is 60 and 2/10, and this is 60 and 1/5, but both of these are saying exactly the same thing. These are representing the same exact number. It's just that they look a little bit different. Okay, so the answer is, this is in degrees. Okay, the answer is, if it's 75 and 3/10 of a degree, and the temperature drops by 15 and 1/10, then in the end of the day, the temperature will be a little bit over 60 degrees. It'll be 60 and 1/5 of a degree. Okay? So subtraction, you see, is not really any harder than addition. The bottom number in the denominator must be the same. And if it is, you just keep it along. And if it's not, we're going to get to a problem here in just a second where we have to do some tricks to make it the same. And the whole numbers get subtracted, and then you just slap it back together as a mixed fraction, and then you simplify your fraction, which you always should do, no matter what problem you're doing, and then you're done. Okay? So the next problem says, James grabs one cupcake, and he eats 1/10 of that cupcake. How much cupcake remains? Okay? So again, you know you're going to subtract here because you have one whole cupcake. You eat some of that cupcake, so you're taking it away. You're subtracting that part of the cupcake. You're taking 1/10 of the cupcake and you're putting it in your tummy, okay? How much cupcake remains? That is what subtraction is. It's taking something and it's taking something away from it. How much remains? So that's how you know that you need to subtract. So this one's a little bit tricky at first because you know he has one whole cupcake, okay? And he eats 1/10 of a cupcake, so you know you have to do a subtraction that looks like this, 1 minus 1/10. And that looks really difficult because you know that in order to subtract fractions, The bottom number, which is 10, must be the same. So I have two problems here. Number one, this isn't a fraction at all. And number two, even if it was a fraction, its bottom number, which doesn't exist, is not equal to 10. So how do I fix this? You must convert this problem so that both bottom numbers in these fractions must be a 10. So that means I need to change this number 1 into a fraction, okay, in order to move forward. So you remember back when you first studied fractions that if I have 3 over 3, this fraction is equal to 1, okay? And if I have 4 over 4, this fraction is equal to 1. And I have 6 over 6, this fraction is equal to 1. And if I have 234 over 234, that fraction is equal to 1. The reason that they're all equal to 1 is that you can look at it two ways. If I have a pie and I divide it into 3 equal parts, which is what this bottom number says, and I take 3 pieces of that pie that I have divided into 3 equal parts, 1, 2, 3 pieces, and I've divided into 3 pieces, I have one whole pie. Okay? If I chop the pie into 4 pieces and I take all 4 of them, I've got one pie. If I chop the pie into 6 pieces and I take all 6 pieces, I've got one whole pie. So anything over itself is 1. Okay? That is true. And you can also look at it from the point of view of division, because I told you before, any fraction is also division. This means 4 divided by 4. This means 6 divided by 6. This means 3 divided by 3. In our big example, 234 over 234, that is 234 divided by 234, which is 1. Anything divided by itself is 1. So it's all meaning the same thing here. Why am I telling you this? The reason I'm telling you this is because you can look at this problem and realize right away that it's 1 minus 1/10, but I can change this. I can make him 10 over 10, okay? And then when I subtract 1 over 10 from him, it's very easy because now the bottom numbers are the same, okay? And I can do this because 10 over 10 is equal to 1, okay? So it looks different, again, but it's actually the same exact number. So I can use this little trick to make him 10 over 10, and that lets me go forward with the problem, okay? So you have to get a little creative sometimes in order to be able to do the subtraction. So now that he is set up like this, he's very easy because the bottom number is both 10, so I can make the bottom number of the answer 10 because he comes along for the ride. And then the numerator, which is these numbers here, are just subtracted. 10 minus 1 gives me 9. Okay, and that is the answer. I cannot simplify this anymore. You can try. Let's think about it. Can I simplify this? What can I divide into 9? I can divide 3 into 9, and 9 divided by 3 would give me 3. But can I divide 3 into 10? 10 divided by 3 is not a whole number, so it's not going to get simpler. Can I do something else? Can I divide the both sides, top and bottom, by 9? 9 divided by 9 will give me 1. 10 divided by 9, again, it's not going to give me anything simple. So I'm basically done. I can't simplify this fraction anymore, and this is the answer. So 9/10 of a cupcake remains. Okay? And you know, it makes sense. It really does. If he has one whole cupcake, which is the same as 10 over 10 pieces of a cupcake when you have one whole one, and you eat 1/10, you should have 9/10 left over. You should have a majority of the cupcake left. And that's all this is saying here. Okay, the next problem says you are flying a kite which is 23 6/7 feet above you. 3 1/3 feet below the kite, the string breaks and the kite flies away. Okay, and the question says, how much string are you left with? Okay, so again, you need to think about this to understand and know if you need to add or subtract or multiply or whatever it is you need to do. Okay, so you have a kite. Let's say this is the kite, and you're flying this kite, and I'm holding the end of the string down here, and this kite's flying, and the length of this is 23 6/7 feet. So it's almost 24 feet. It's just, it's more than 23. It's less than 24. It's 23 6/7 feet high. Okay. Now it says 3 1/3 feet below the kite, which would be down here where my thumb is. It breaks. Gone. Kite flies away. Okay. How much string do I have left with, which is this part down here? So you know that you're going to need to subtract here because you've got this much string to begin with all the way up to the kite. The kite takes away 3 1/3 feet with it because it flies away with 3 1/3 feet of string. How much do you have left? That is subtraction. You start with a number, you take some of it away, how much do you have left? So you know you're going to have to subtract. Okay? If you were going to draw a picture, you could draw a little picture for yourself, and you could say, well, this is the kite, and here I'm holding on to it here, right? This is me holding on to this thing down here. And you would say to yourself, you could say, well, the entire length up here is 23 and 6/7. Okay, that's how long it is. And then you could say that it breaks right here. Okay, and it breaks at 3 1/3 feet. Okay, so I've got this much string to begin with. 3 1/3 feet goes flying away when the string breaks. How much do I have left? So I have to subtract these numbers to find out how much I have left. So let's do that. 23 6/7 minus 3 1/3. Now, without a lot of practice that we're getting here, you might look at that and say, whoa, that's very difficult. But in fact, it's not difficult. Let's just take it one step at a time. You have 23 and a little bit more, almost 24. That's what this fraction means, 23 6/7. You're pulling away from it 3 and a little bit more, 3 1/3 feet. So I know I can subtract my whole numbers. We've been doing that all day. 23 minus 3 gives you 20. Okay, so I write that down. And then the next thing I need to do is subtract my actual fractions here, which is 6/7 minus 1/3. Okay, so I'm halfway home. I've subtracted my whole numbers. I got this. Now I subtract my fractions. And I'm going to stick them back together at the end as a mixed fraction. Okay, now what's challenging is you see that these bottom numbers are different. Okay, you see that those are different, and you need to, in order to subtract fractions, or to add them even, you have to have the bottom number of the fractions the same. You cannot subtract them, you cannot add them unless they are the same. Okay, so we have to make them the same. What we're going to do then, in order to make that happen, is we're going to play around with this a little bit. What we're going to do is we're going to break this out. This is 6/7 and we're subtracting 1/3. Okay? Now remember, I need to make these bottom numbers the same in the final fractions that I actually subtract here. And I can do anything I want to the top and the bottom here. I can divide by numbers, I can multiply by numbers, as long as I do it the same to the top and the bottom. Now notice, if I were to multiply this fraction, both top and bottom, by 3, then on the bottom I'd have 7 times 3, which would be 21. And then over here, if I multiplied this fraction by 7/7, then 3 times 7 on the bottom would also give me 21. So what I'm going to do is I'm going to multiply this fraction by 3/3, and I'm going to multiply this fraction by 7/7. And notice I'm not changing anything with the problem. The dot here just means multiplication. That's all it means. It's just a dot that means I'm multiplying them together. And when you multiply fractions, you multiply the top and you multiply the bottom. And that's all you do. It's very simple. You multiply the top, you put a line, and you multiply the bottoms. So you see here, I did this because 7 times 3 is going to give me 21, and here 3 times 7 is going to give me 21, and then I have 21 on the bottom of each one, and I'm going to be able to subtract these fractions. So let's do that. Let's pull this multiplication off. We have to multiply the top, which is 6 times 3 is 18, and the bottom is 7 times 3 is 21. We're subtracting this thing. 1 times 7 gives us 7, and 3 times 7 gives us 21. Okay? Now, in the end, we've got fractions that have 21 on the bottom. Now, I want to just make sure you understand that these fractions, even though they look totally different from these up here, they represent the same exact number. That's what I was telling you before. You can multiply the top and bottom. It's kind of like the seesaw I was talking about. You can do the same thing to the top and the bottom. You're okay. It's the same number. It just looks different, but it's the same number, okay? So 18 over 21 is the same exact thing as 6/7. And 7 over 21 is the same exact thing as 1/3. And the reason they're the same is because here all I've done is multiply by 3/3, which is just multiplying by 1. And here I've multiplied by 7/7, which is just multiplying by 1. So I did that so that I could get this bottom number the same. Okay? So now that we have these the same, I just go ahead and solve the problem just like we've been doing. The bottom number is going to be 21. He just comes along for the ride because this bottom number is the same. He just comes along for the ride. And now 18 minus 7 on the top starting at 18, 17, 16, 15, 14, 13, 12, 11. So I've taken away 7, I've got 11 left over. So this fraction minus this fraction is 11 21st, or 11 over 21. And then putting them together, just as a mixed fraction, 20 and 11 21st. That is how many feet remain. Feet of string. Okay? So if you were flying a kite that was 23 7/6 feet tall, and if the kite breaks, taking away with it 3 1/3 feet, then once you subtract these fractions together, you're going to be left with 20 and 11 21st feet, which is, you know, more than 20 feet, less than 21 feet. That's what this fraction is. It's just part of a foot. Okay? The thing to remember is you subtract your whole numbers, you keep that, and then you subtract your fractions. The only trick here was that because these numbers were different, I had to multiply these fractions by something in order to get the bottom number the same. It didn't have to be 3 over 3 and 7 over 7, but that's what I chose because I knew that 7 times 3 would give me 21, and I knew that 3 times 7 would give me 21. As long as I'm doing the same thing to the top and the bottom over here, and the top and the bottom over here, I'm okay, because I'm just multiplying by 1, and I'm multiplying by 1, so I'm not changing anything. Once I had the bottom the same, you just do it like normal. The bottom number, the denominator, stays along for the ride, the top numbers get subtracted, and that is the end of the problem. So try to get comfortable with that. It's not that hard, but it does take practice, okay? And we're going to get practice with that now. The next problem says a pipe is 6 2/3 feet long. Jenny cuts 1 1/4 feet off, and James cut an additional 2 1/12 feet off. How much pipe remains? You're going to know right away that you need to subtract these numbers because just thinking about what it means, you start with a pipe that's 6 2/3 feet long, this long let's say. Jenny comes along, cuts 1 1/4 feet off. Somebody else named James comes along and cuts another 2 1/12 feet off. So I'm cutting and cutting and cutting, and that is just going in the trash can. How much pipe remains? That is subtraction. You've taken some pipe, you've thrown it away. How much remains? Okay. So you start out with 6 2/3 of feet of pipe, and you subtract from it 1 1/4 feet of pipe, okay? And then you subtract from that 2 1/12 feet of pipe. So there's no big mystery here. You start with this much pipe, somebody cuts off 1 1/4 feet, and somebody else cuts off 2 1/12. So I'm cutting them off, I'm subtracting them out, I'm throwing them away. How much do I have left? Okay? So this is no different than anything else. We can deal with our whole numbers first, then we can deal with our fractions, okay? So let me ask you, what is 6 minus 1 minus 2, if I'm just going to deal with the numbers? 6 minus 1 gives me 5, and 5 minus 2 will give me 3. So I can put a big fat 3 down here, and I've done part of the problem already. 6 minus 1 gives me 5, 5 minus 2 gives me 3, so I put the 3 there. And now I'm going to deal with the fractions, and I'm just going to rewrite them here, because I like to keep things clear. And by the way, I'm not even doing this totally just to make it clear to you watching the video here. I do this when I work these problems myself. The number one thing that can get you into trouble is trying to skip too many steps. It's just try to start subtracting these fractions in your head and trying to do the denominator and all that without showing every single step. You're going to get into trouble. So make sure you do every line, making sure each step goes into the next step and it's correct, okay? So I have my 3. Here are the fractions I want to subtract. I haven't done anything. I've just written them down, okay? Now we have a problem because these denominators, these bottom numbers are all different, okay? They're all different. But notice that here I have a 12, here I have a 4, and here I have a 3. And those 3 numbers, if you think about it, are kind of related because 3 divided by 4, 12 divided by 4 gives me 3, and 12 divided by 3 gives me 4. So both of these numbers, 3 and 4, are both divisible and can go into 12. Okay? So they're kind of related. They're not just total random numbers here. So what I want to try to do, since I know that 3 times 4 will give me 12, and since I know that 4 times 3 will give me 12, I need to multiply these fractions by something to give me a bottom number of 12 here and a bottom number of 12 here, and I've already got a bottom number of 12 here, and then I can actually do the subtraction. And I know I need to deal with 12 because I know that 3 can be multiplied by something to give me 12. 4 can be multiplied by something to give me 12. Okay? It comes with practice. It comes with experience. That's why we're doing this stuff. So I'm going to write it down again because I'm going to hopefully make it clear what I'm doing. So I'm going to give me some space here. Okay? We already said, whoops, this is 12 over here. We already said that 3 times 4 will give me 12. So if I multiply this by 4 over 4, 3 times 4 will give me 12. So I have the same bottom number. I have to multiply the fraction by the top and bottom number, the same number, and then I'm multiplying by 1. I'm not changing anything, so that's what I'm doing. This fraction, 4 times 3 will give me 12. So if I multiply this by 3 over 3, then the bottom number will be 12. 4 times 3 is 12. And then I have a bottom number of 12. So in the end, I'm trying to get a bottom number of 12, bottom number of 12. This one's already bottom number of 12. Then I can move on. And I can actually do the subtraction. So let's do it. Because I'm doing multiplication, I have to multiply the top and multiply the bottom separately. 2 times 4 gives me 8. 3 times 4 gives me 12. Minus, because I'm subtracting. 1 times 3 gives me 3. 4 times 3 gives me 12. Minus. 1/12. I haven't done anything with him, so I just bring him along for the ride. So now I'm subtracting these 3 fractions, and now it looks beautiful because I have 12 in every single bottom number. Okay, so now we can do our subtraction. Okay, 12 is going to hang along for the ride. It's going to stay in the bottom. I'm not going to change him because he's all the same, and he just stays along for the ride. 8 minus 3 gives me what? Starting at 8, subtracting 3. 7, 6, 5. Okay, 8 minus 3 gives me 5. Minus 1 more gives me 4. So it's 4/12. That's the answer to that. And so in the end, I'm going to have 3 and 4/12. And this is the answer, but you need to always ask yourself, like we always do when we get to the final answer, can I simplify this fraction anymore? Can I divide this top number and this bottom number by something to make this fraction simpler? And I think you can see that if you divide the top number by 4, 4 divided by 4 would give me 1, and if I divide this by 4, 12 divided by 4 will give me 3. That's going to be simpler. So 4 divided by 4 gives me 1, 12 divided by 4 gives me 3. And this is as simple as you can go. You can't do anything else. So you have 3 1/3 feet of pipe left. Okay, and that is the answer. Okay, if you start with 6 2/3 feet of pipe, you subtract off 1 1/4 feet of pipe, and you subtract off another 2 1/12 feet of pipe. Going through it, you will have 1 1/3 feet of pipe remaining. The only thing that was tricky about it was I had to subtract my whole numbers, and then I had to deal with my fractions separately, and I had to find the common denominator. That's what this is called, finding the common denominator of these fractions. And I did it by multiplying top and bottom of these fractions by a common number to make this bottom number 12. That's the way I tackled this problem. And it follows a pattern. Okay, it's something that you can practice and you can get good at by working, lots and lots of example problems. Okay, so the final problem goes like this: you have 10.5 pounds of jelly beans. Okay, your brother steals 3 1/6 pounds, but your sister adds 2 pounds more jelly beans back in. How much do you have? How many jelly beans? How many pounds of jelly beans do you have? So here, it's a little bit more complicated because you have 10.5 pounds to begin with of jelly beans. Your brother takes 3 1/6 out. Okay, so that's going to be subtracted out. You're subtracting 3 1/6 out because he steals them. But your sister adds 2 more pounds back in, so that's going to be added back in. And so the question is, how much do you have in the end? So I think from talking about it, you can understand that you're going to be doing some adding and you're going to be doing some subtracting. You start with 10 1/2 pounds of jelly beans, and your sister steals 3 1/6, which means it's subtracted out. You subtract him out, and your brother steals that, the 3 1/6, and your sister adds 2 more pounds back in. So all you need to do is subtract this amount and add the 2 back in, and then you will have the answer. You'll know how much you have, how many jelly beans you have. So just like before, you can deal with your whole numbers first, okay? And then you can deal with your fractions, okay? So what is 10 minus 3? Okay, 10 minus 3 will be 7 because starting at 10, 9, 8, 7. subtracted 3, I got 7. 10 minus 3 gives me 7, plus 2 more because this is a whole number. 7 plus 2 is going to give you 9. So you put 9 here. That's your whole number. 10 minus 3 gives you 7, plus 2 gives you 9, so you put that down. Now you deal with your fraction. 1/2 minus 1/6. There is no fraction over here. This is just a whole number, so you don't have anything there at all. Okay? You're just dealing with your fractions here, and you've already done your whole numbers. Now notice that this bottom number is not the same, so you can't just subtract those two things. You have to do some work first. Okay? And so I'm going to write this down so I can write it in blue and make it really clear what we're doing. We need to find a common denominator. And what we notice right away is that the bottom number here is 6 and the bottom number here is 2. Now if I take this 2 and multiply it by 3, I'm going to get 6. And that's going to give me the same common denominator. So I'm going to do that. I'm going to multiply this by 3 to give me 6, but I have to do it to the top too in order to make it legal because I'm multiplying by 1 since 3 over 3 is 1. Okay? Now when I do that, 2 times 3 is going to be 6, which is going to be the same as 6 here, so I don't need to do anything to him, okay? Because he's already 6. Okay, so I'm just going to do that. 9 plus, and inside here, multiplying the top, 1 times 3 gives me 3, and the bottom is 2 times 3 gives me 6, minus my 1/6 that I had. Okay, and I'm just grouping it in parentheses here just as a reminder to me that I'm doing this separately. This has really nothing to do with the math. You could drop them. It just helps me keep these together. Okay, so now I'm going to subtract 3/6 minus 1/6. Okay, what is that going to be equal to? Well, 6 is along for the ride because now we have the same denominator. You leave him alone. You don't subtract him. You don't add him. You just leave him alone. And now we can subtract 3 minus 1 will give me 2. So it's 9 and 2, 6. This is my mixed fraction. That is my answer. But you always need to ask yourself, can I simplify this fraction? Can I divide the top number and the bottom number by something, the same something, and make it simpler? And the answer is yes, you can. Because if I divide both by 2, 2 divided by 2 will give me 1, and 6 divided by 2 will give me 3. Because 3 times 2 is 6. Okay, so the answer is 9 1/3 pounds of jelly beans. Pounds of jelly beans remain. That's how many remain. So if you start with 10.5 pounds and you subtract out 3 1/6 pounds, but then you add in 2 pounds, you're going to be left with 9 1/3 pounds of jelly beans left over. Now this problem was a little bit interesting because it had some addition and some subtraction. You see, there's no canned way to tell you when to do adding and subtracting. That's why you must read the problem and then figure out what to do based on what it says. So don't blindly start doing work. Don't just start doing something just to do it. You need to understand. In this case, we knew the brother was stealing some jelly beans and then the sister was adding some back in. So we knew we were going to have some addition and some subtraction going on in the same problem. Okay, now this section's really great because you're subtracting fractions and it's very similar to adding fractions. The only thing you need to remember is that the bottom number, which is called the denominator, needs to be the same in a fraction in order to subtract it and in order to add the fractions. And if they're not the same, you need to make them the same, and you do that by multiplying top and bottom of those fractions by something. Because you're just multiplying by 1, if you multiply by 3 over 3 or 4 over 4 or 5 over 5, you're just multiplying by 1. And your goal is to make those bottom numbers the same. And once you do that, then it's very easy because the bottom number comes along for the ride and the top numbers just simply get subtracted just like we did here in these problems.